Okay, power is really straightforward. It's basically this equation. Power is equal to work over time, or however much energy was exerted over time. So we're going to measure that. The units for power are watts, which abbreviate with AW. Okay. Let's do an example problem. Let's say you exerted 1,000 joules of energy as you climb from the bottom of a staircase all the way. This is a terrible staircase. Don't climb these stairs. They're dangerous. To the top. Now let's say that it took you 60 seconds to do that. So you would do power is equal to work divided by time. So power is equal to 1,000 divided by 60. So power is equal to 16.7 watts. Done. That's it. The only situation where they can make it a little bit more complicated, but it's not even that bad, is where we have a type of energy changing from one thing to another, and you first have to solve for the work. So let's say, for example, we had somebody with a jetpack, and she started out with a kinetic energy of, 2,000 joules. Okay, and she fires her rockets even faster, and so she ends up with, quick stick figure here. This is a jetpack. That's, I don't know, something happened to her feet. It's a terrible accident. We can't talk about it. So she went from having 2,000 to, let's say, 6,000 joules, and all that happened, including the terrible foot accident, in the space of 120 seconds. Okay, so in order to do work, and she didn't change height during that time. So work would be the change in kinetic energy. So K final minus K initial, or 6,000 minus 2,000. So our work here would be plus 4,000. And that's how much work was done from this position to this position. So power is equal to work divided by time. So 4,000 divided by our time is 120 seconds. And we get 33.3 watts. That's about all there is to that type.